Welcome, students. We're starting our unit on equations and inequalities, and this first lesson is probably our longest lesson, so shake those hands out, get ready here. I apologize, but you know how these front lessons usually front load that skill we're about to learn and recycle throughout this unit. So you can see the two standards you need to copy down. We're learning 7EE4A and 8EE7B, and we're going to focus on some properties first, but I'm going to ask you to pause right now and copy these two slides down for me. Thank you. Okay, so welcome back. I won't make you write the full standards each note, but I do want you to have it on the first note of this lesson, and anytime it changes, I'll let you know when we have to write the full note. So our essential question today is how do we solve equations that have addition, subtraction, or multiplication, division? So we're going to learn how to get rid of one of those operations at a time in this note. And again, the next three slides are going to focus on properties, and really these properties all have a common feature. We have to be fair. And remember, this is kind of recycling through all of the math world. It's that perfect world. Just like in fractions, when we had to change the top of a fraction, you also had to change the bottom. Those numerator and denominator both needed to be changed. So in this one, what we're learning is that if we add or subtract on either side, as long as we do it to the left and the right, it is going to be equal to each other. So we draw a line. We're going to learn how to use this skill a little later on. And right here, we have a minus 9. So the inverse of a minus 9 would be a plus 9. And this thing we're using is called the additive inverse. And I'm going to interchange these vocabulary as we go. Sometimes I'll say we're using that additive inverse. Sometimes I'll say I'm using the inverse operation at the time. And if I wrote plus 9 on the left, I also have to write plus 9 on my right. And everything else comes down equals. And we're learning a new notation here. Mathematicians, as we know, are efficient, and they don't like to write a bunch of things. So instead of writing a 0 on the next line, they write an arrow through it with a 0 on top. Just always make sure those two numbers are in fact opposites and adding to 0. And then m plus 0 is m. So we got our answer, m equals 33. Remember, I know many times you're able to pretty much guess what goes here, but remember these skills are going to get used on harder problems, so don't try to just use the guess and check method. I'm going to ask you to pause one more time and copy down these two slides. Welcome back, students. Okay, so on these ones, we're learning about the multiplication and the division. Again, we're being fair here. We have to be fair. Whatever we do to our left, we also have to do to our right. So to get rid of this rational coefficient, we're trying to make the number 1 here, and we're going to use what's called the multiplicative inverse. And if you're having trouble at all on the wonderful smartboard spellings, just remember the vocab we have on the other lesson video lecture can help you out if you need that and you have it written down on your Cornell note. So what is the multiplicative inverse? Remember, that's just a fancy word for reciprocal. As I sometimes call them, I call them reciprocals or reflippicals. That's what we do. And if I wrote times 3 halves on the left, I also have to write times 3 halves on the right. These reduce down to the number 1, and 1 times x is just an x, which equals, and the 2 and the 4, I like to use this to show that this is just fraction multiplication, which we already know how to do. Remember, it's just fraction multiplication. These reduce by 2 to make our math easier, and 2 times 3 is 6, so the answer for that is 6. And once again, notice it was a little harder to do that problem in your head. I'd like to make that happen on purpose so you realize we have to learn these skills. So again, on the division property of equality, it's just being fair. Whatever I do to the left, I have to do to the right. We're going to draw a line here, and this time we're actually working on the right side first because we always work on the side with the variable. And what operation is in between -7 and y? You're right, it's multiplication. So how do we get rid of multiplication? The inverse operation of multiplication is division. So we're going to write division bars this way. Please try not to use this symbol for the division. We're trying to embrace this fractional use of math there. And -7 divided by, we need to divide by -7. Notice our numbers when we use multiplication or division, the signs don't change. If I wrote that on the left or right, I have to write it on the left. So -7 divided by -7 is 1, and 1 times y is y. And we love fractions because that's the answer. That's in simplest form already. So y equals -5/7. And again, we're about to use these skills, and I have a couple steps on the next slide here. I'm going to ask that you pause one more time and copy these down. Okay, welcome back after copying that down. So how to solve equations with addition, subtraction, multiplication, or division. We're learning on these how to do it one operation at a time. So only if one's there. And you can probably hypothesize that in the future we're going to start using our multiple operations at a time. So step one says use the inverse operation on both sides of the equal sign. And remember the goals in these problems, this is what this essential question, or sorry, this question over on the left margin is telling us, is focusing on, we work on the side that has the variable. And that variable could be on the left, it could be on the right, it may even switch sides throughout the problem. So just be aware of that. So we're going to draw our vertical line on the equal sign. And the operation in between 4.2 and x is multiplication, so we have to use division. And we're dividing both sides by 4.2. And really that's just a negative and a positive, which will get us a negative answer. I like to put my sign down there first so I don't forget it later, you know me. And then we have to do our division. Normally I would do this on the side of the math problem, but I don't have much space on the smartboard. And we're just doing our division of our rational numbers here. Remember, in division, that's where I do like you to use your guess and check. I think that's going to be it. I think that's 42 times 5. It is. Even if that's a wrong guess, remember, it helps us figure out if we have to go higher or lower on the next guess. So that terminated. The answer is, for this problem, is negative 12.5. And notice I'm always trying to pull my answer off to the side. It says I'm double checking it's correct. And we're about to use some examples here. So, in example 1, we have 10 equals h plus 3.4. We're going to draw our vertical line here. We're working on the right side on this problem because that's the side that has the variable. And we're trying to get rid of this plus 3.4. What's the additive inverse? What's the opposite of plus 3.4? Yeah, it's negative 3.4. And if we write that on the right, we also have to write that on the left. Remember, line up those place values. And we have h come down on this side. You can add your zeros there. Decimal point comes down. And don't forget the equal sign. That's going to matter later on when we have inequalities that we have to bring down. So the answer for this one is h equals 6.6. Great job. Hey, on number 2 here, we're going to draw our vertical line. We're trying to get rid of this negative 5.4. So this is where a lot of students get confused. They see this plus sign on right here, and they go, oh, use a minus. But we're trying to turn negative 5.4 here into a 0. So what number can you add to negative 5.4 to make it a 0? Positive 5.4. And again, I like to try and get these types of examples in there because the problems like to do it. And k equals 8.52. Remember, ask questions in class, mark anything you want down in these margins. They're here for you, and ask them later. I'm here in class to help. And I'm going to have you copy down these next 2 slides. Try and hit pause and do that for me. Okay, welcome back, I believe. These are our last 2 slides, so I'm going to show these last 3, 4, and 5, and then we'll go over the word problem number 6. So on number 3 here, we draw our vertical line, and we can make 6 over 11 go away using the multiplicative inverse. That's that fancy word for reciprocal. And those reduce down to the number 1. 1 times y is y. Oh, wait, hold on. What is that? I didn't be fair. I need to write it on the other side. And again, remember, this is just fractional multiplication. What do 14 and 6 have in common? At 2, we can reduce them down. 7 times 11 is 77 over 3. And that's the answer. We don't have to do that into a decimal. We can leave it in a fractional form. On number 4, I like to show these next two examples because students sometimes feel like the answer we're about to get in our final solution here, it can't work. This number is not possible, but it is. So we're trying to get rid of this plus 31, and we write minus 31. We have to be fair, and this is where a lot of students pause in their math problem, and they go, wait, that's a 0. That can't happen. But it can. That is a number, and it's allowed to happen. So the answer to that is x equals 0. In fact, that's the additive identity property. Okay, so number 5, we draw a line. How do I get rid of that 5? I'm going to show it using the multiplicative inverse. Its reciprocal is 1/5. 0. 0 times anything. Wait again. That can't happen. It's a 0. Yes, it can. Remember that. Zeros are numbers. They are allowed. It's a 0. So y equals 0 in that problem. Okay, and our last example, the word problem, and we're going to use our marking the text skills. So we should be trying to circle the things we care about. And I'm going to have you pause for you to try and circle what you care about. Okay, so we got that. Did you circle what you cared about? So we're reading it along, and remember, we get really lost in these word problems, but everything is done just the way we read it, done from left to right. So we have that $12.50 per person. That seems like we're going to multiply that for admission. After 1 hour, a lot of students are going to be circling that 1 hour, I bet. The show had already made $675. They made $675. Okay. I like the made to show it's a positive number. And then it says write and solve an equation. Okay, so we have our equation. Do you remember what per means to do? Do we actually know the number of people who went into this magic show? We don't. So that's the variable. Remember, when we're like, we don't know how many people went, that's the variable. So it's going to be 1250 because we read that number first. Per means to multiply in this case. And person, we're going to use the letter P. So we're just going to write 1250p. And they made, so that's how much they equaled. And they made how much? $675. So that 1 hour was kind of the red herring number. We don't have to use it in this problem right now. So we need to draw our vertical line on our equal sign after translating, because remember the directions did say write and solve. Always read those directions so you know if it's asking for just writing it or if we also have to solve the problem. So the operation in between 12.50 and p is multiplication, so the inverse of that is division. And I'm going to write it as 12.5. We don't need that last decimal place. This side is going to be p all by itself. And then remember, in these real world problems, we're hoping that we don't get a fractional answer because it's really not possible for half a human to show up, I hope. That would be kind of scary, huh? So we got to move those decimal points. And 125 goes into those 0 times. Remember, I like to show that guess and check method for long division. I don't know all the multiples of 125, so I don't expect you to either, but it is good to try it out and see. Oh, okay, so that worked. Bring down to 0. Again, we're going to use that guess and check. I think it's going to be 4. Oh, it is. And it was 4. So we had 54 people come in. And remember, that sounds logical. Since it's not a decimal, we didn't want one, or else there would be some weird fractional arm walking through the gate. So the number of people was in the first hour was 54 people. We're going to write our summary in class tomorrow. But thank you so much for giving me this long lecture here. We'll try and abbreviate the next few. This is just that front-loading lesson, so it's really important. We're going to use these skills actually multiple times in one problem. So I'll see you tomorrow, and thanks for listening.